Hello friends, this video on States of Matter Part 25 is brought to you by examfear.com. No more fear from exam. Before watching the video, please make sure that you have watched Part 1 to Part 24. Let's take one interesting question. The payload is defined as the difference between the mass of displaced air and the mass of balloon. We have to find the payload when the balloon of radius is 10 meter. Mass of the balloon, this mass is 100 kg. 100 kg. Is filled with helium gas. So to find the payload. Payload is nothing but difference in mass of displaced air and mass of balloon. Correct. That means, see, the way this hot balloon works is, if you have a normal air here, it will have some volume, it will have some weight because it will have some density. So you have my volume of normal air, or I can say the mass of normal air, my mass of normal air. So now what I do, instead of normal air, let's suppose the mass was big mass, instead of normal air I put now helium gas. That will have less mass because my helium is lighter, right? And also the weight of the balloon. So this is something which is, if this value is some positive number, that means it will float, it will fly up. Why? Because the expectation was, because the pressure around this area will have ability to maintain this mass. But now instead of this mass, I have a lesser mass. Let me do like this. I have a lesser mass. The new mass is the mass of this helium gas and the weight of balloon. If this is lesser than the mass of normal air, which should have been there if in the normal, if there is no balloon here, right, they should consider this much area has this much normal air, right? So if this weight, and if you compare these weight, if this weight is lower, it will go up, correct? Because if this weight is lower, it will go up because it was expecting this much weight. Now you're reducing the weight, it will go up. Because if this weight is this much, it is balanced. If you decrease the weight, it will go up, correct? So we have to find this value, mass of normal air minus mass of helium gas and the weight of balloon. So weight of balloon we know is nothing but 100 kg. So we have to find these values in kg. So we know the formula, but for the formula in the volume of the balloon. So volume of balloon is nothing but 4 by 3 pi r cube. We'll assume it's square. So this comes to be 4 by 3 pi, we'll do by 7. R is what? R is, radius is 10 meter. 10 cube. So it comes out to be 4190.5 meter cube. Please note the dimension, it is meter cube. This is the volume of the balloon. So if this is the volume of the balloon, the volume of displaced air, the normal air is also same, this much. This is my volume of balloon, and this is also my volume of displaced air, right? Because the air occupied the whole balloon. So if I want to find the mass of displaced air, normal air, so mass of normal air or displaced air is nothing but density into volume. What is the density of normal air? Is 1.2 kg per meter cube. So with this I have to give volume in meter cube. Volume in meter cube is 4190.5 meter cube. Meter cube cancels. What you get is 5028.6 kg. That's why we wrote dimensions. With dimensions, if you see, things are clear. Had this been in centimeter cube, we have to convert it to meter cube only, because my question demands that way, because my density was given per meter cube. So I have to give volume in meter cube only. So I got this kg. So mass of normal air is 5028.6 kg. Correct. Now I have to find the mass of helium. I have to find the mass of helium. that is inside the balloon, because we have replaced the normal air with helium gas, which is lighter. So mass of helium is nothing but capital M molar mass PV by RT, this formula we have. Let's put the values here. So what is the value of molar mass of helium? 4. Pressure. So for pressure, first we use the value of R, which will decide the pressure units. R we are using is this guy, 0.083 bar dm cube per Kelvin per mole. Right? So this gives, I need pressure in bar. So the pressure in bar is 1.66 bar given, right? And then I have to give volume. Volume has to be in dm cube now. Correct? So I have made it in meter cube, so I'll just convert this into dm cube. It came out to be 4.1095 meter cube. So I'll make it into 10 to the power 3 dm cube. Correct? Because this is requires in dm cube. Temperature is in Kelvin. 27 degrees Celsius is nothing but 300 Kelvin into 300 Kelvin. So this whole thing will come in gram. So this comes out to be 1117.5 into 10 to the power 3 gram, and that is nothing but 117.5 kg. Why gram? If you see, this has to be in gram because the unit says so, right? Because this 4 was in 4 gram. Bar gets cancelled, dm cube gets cancelled, and kg gets cancelled. So I get 4 gram. In gram, I convert it into kg, I got these values. So this is my 1117.5 kg. So everything is in kg, I can apply maths here. So my payload will be this value, 5028.6 minus this 117.5 minus 100 in kg. Right? Or you can do like this also. Kg. So you solve this, you get 3811.5 kg. And since this is positive, it will fly, it will go up. Correct? And that is the payload of this balloon. So see, with this what we are achieving is by filling this with the helium gas. So we are creating a vacuum of 3811 kg here. Right? If you add 3811 kg in this balloon, it will stop because in that case it will be equilibrium. Since we are creating a vacuum of 3811 kg, it will fly, it will go up. So pretty straightforward question, easy question. We have to find the volume occupied by 8.8 gram of carbon dioxide at this temperature, this pressure. So we just use the formula PV is equal to nRT. So but N is not given, we have mass given and molar mass we know. So we can use the formula mass by molar mass RT. So to find the volume, so V is nothing but mRT by, this is the formula. So first thing we'll do, we'll put the value of this is 8.8 gram M. What is the value of R? R is given 0.083 bar liter per Kelvin per mole. Okay. T has to be in Kelvin now. So T is 311.1 degrees Celsius. If you convert to Kelvin, you add 273.15 to this. So you get 304.1 actually. So this becomes 304.1 Kelvin. Divide by M. P. So what is M? M is the molar mass, 44 gram of CO2 into P. P has to be in bar. P is given in bar, 1 bar. Now we'll cancel stuff, gram cancel, bar cancel, Kelvin cancel. Right? And this is gram per mole, I think. Yeah, gram per mole. So mole also gets cancelled. So what I get? Volume as, if you multiply this, you get 5.05 and the unit will be, what will be the unit? Liter. This is remaining. Liter. And that is the answer. Correct. Thank you. Visit examfear.com to watch free educational videos, try free online tests, get the best quality study materials, study from the best tutors and mentors, and much more. Thanks once again.